All right, here's the step one question of the day. Like and subscribe if this content is helpful. 63-year-old woman has a 3-week history of headaches that are intense in the morning, caused by and accompanied by visual disturbances. She's got a 1.2 centimeter asymmetric darkly pigmented lesion. Here is a picture. Which of the following is the most likely risk factor? So this one is fairly easy because it is a melanoma. You can tell by its irregular borders, and so it's not going to be the sun. It's going to be the sun exposure. Ingestion of the smoke meats, asbestos. We'll go over what each of these are. So yes, this is metastatic melanoma. It's caused by brain metastasis, like the headaches and visual changes would be caused by that. Melanoma, can metastasize to the brain, liver, lungs, and bones, and it can cause hemorrhagic brain lesions. So sun exposure causes this, and it'll induce the pyridamine dimers of DNA. And if those aren't repaired and you have like a condition like xeroderma pigmentosum, that can cause a mutation and cancer. And we'll have another question about that soon down below. So why the other choices are wrong. So the first one, aniline dyes, this is linked to bladder cancer. Anytime you see asbestos, this is a mesothelioma, so it's linked with pleural cancer. And polyvinyl chloride is linked with hepatic angiosarcoma, so liver cancer. Ingestion of smoked foods, that's gastric cancer. Commonly found in Japanese patients or those who have spent a lot of time in Japan, rather. A super simple breakdown would be melanoma. Anytime you have the ABCDs, the asymmetric, irregular borders, you have discoloration, and yes, this has a risk of spreading to the brain. Too much sun will cause this, so that's the right answer. Next question here, it's a similar question, and here we have a six-year-old boy is evaluated for rapidly growing mole on his shoulder. His parents mentioned that he develops severe sunburns, and that's just with minimal sun exposure. And otherwise, he's healthy. He has freckles all over, and there's an asymmetric mole with irregular borders. Okay, so it sounds kind of similar. This is deficient in a DNA repair mechanism of which condition? Here you can see the correct answer is nucleotide excision repair. This is xeroderma pigmentosum. So it's the same kind of deal here when we have the sunlight UV exposure is damaging the DNA, so these pyridamine dimers are being damaged, and there's a deficiency in the nucleotide excision repair, and that deficiency in nucleotide excision repair is the correct answer for this question. All right, so that is responsible for correcting the bulky helix distorted DNAs, and that's DNA accumulation is caused by UV light, so the sun. It's not base excision repair, because this fixes the small, non-bulky DNA lesions from deamination or oxidation. It's not involved in the UV like the pyridamine dimers. Okay, so this is just the very small one. That would be a single base, not an entire dimer. The homologous recombination, that would be a double-strand break using sister chromatin template. That's like with the BRCA mutations and the breast ovarian ones, not the sun or skin with the pyridamine dimers. So this would be double-strand entire breaks, which would be repaired with homologous recombination. Mismatch repair, that'd be just a replication error. That's like in Lynch syndrome, the CEO, Lynch colorectal cancer. Non-homologous end joining repairs double-stranded breaks without a template, and that can cause some loss of the nucleotides. So that's ataxia telangiectasia, and not DV-induced cancer. So the simple breakdown here, this is an example of a girl with xeroderma pigmentosum. The sun damages you, extreme sunlight, and you cannot, because you have xeroderma pigmentosum, repair through nucleotide excision repair, and that causes you to have this damage that you can see here, or in that case, in the question stem, a mole on the 6-year-old boy. So hopefully this was helpful. If so, like and subscribe. More questions coming in Derm.